Hello, today we're going to cover creating NATO dictionary conversions within Watson Assistant. I've created this deck, but I'll also be sharing the actual links to the documents as well as the Assistant skill JSON payload if you want to try this out yourself. This deck also covers a few other methods. We're going to skip those and go straight to the NATO dictionary section. So here we are. As a bit of a background, there may be occasions where you want to use a phonetic alphabet to make sure that references to enunciated letters are clear. And this can be important if there's uncertainty about the listener's situation or their environment, as well as possibly the speaker's ability to be clear or articulate. This, of course, becomes incredibly important when we're using automated bots because we don't know exactly the environment that the customer is calling from. And there are times if the voice itself isn't clear that the user may need some additional clarification. So there are many different types of phonetic alphabets. I've tried to add a link if someone wants to go research this. I was surprised at how many there are. And so anyways, I gave a link to a number of them. I think the one that I'll be using for illustration purposes, at least, is MJ's phonetic alphabet. I'm not sure who MJ is, but these are the conversions I used. But of course, here's just a reference to, 4 or 5 different alphabets. Any of these could be used, and any of these will work using the tooling that we're going to discuss today. I do give an example here of when you may want to use this if you're going to give a customer a serial number or a phone number, a password, or any sort of string that you need to read back to the customer for validation. In order to set this up in Watson Assistant, there are really 3 major steps. The first is to take the string. So let's just use the example that it's a password. So you take this password string and you're going to want to parse it, which means basically separate it into each unique character in that string. You're then going to need to build a phonetic dictionary and look up each one of those characters, and then of course read back the translation to the user. So let's go ahead and look at each one of those steps. So for parsing the string, we're going to isolate each character of the string and then save it to its own variable. I'm going to actually move to the skill in just a moment, but before we do that, I just want to walk through each of these steps so that conceptually the model of what we're trying to accomplish is clear. So in this particular example, if you look in the image that I've pasted in here, we have a value on the right, and what that is I've used some sort of method here to take the password itself and start breaking apart each one of the strings and parsing it into the individual characters, and then I'm saving them into a variable. In this case, each one of the variables I've given a character number. So if you look on the left here, password character 1, password character 2, and password character 3 are each different variables that we're saving each one of these characters into. So if, for example, the password were ABC123, password character 1 would attain the value of A. Actually, in this case, it's a capital letter A, but we're just going to save it as the A that it is. And for password 2, it'll be a capital letter B, and for password character 3, and so forth, all the way through to the number 3. So the first step is parsing the string. And again, we'll go over this in just a second in the actual skill, so I can show you how to set this up. The next will be to build the phonetic dictionary. Now, in Watson Assistant, the way that we're going to approach this is we're going to create an array, and the array will essentially be a sets of key value pairs. So we're going to tell it, if you see a capital letter A, then the value that we want to return is capital letter A, as in apple. It's the same for B and the same for C. And then for the lowercase, you can handle that however you want. If you want to say lowercase b as in boy, you can do that, or you could just say b as in boy. The structure is the important thing. What you actually seed it with, or the content of it, is at your discretion, of course. So we're going to build this phonetic library. And now once we've parsed the original string and we built that phonetic library, then we just have to actually go through and pull each one of the associated values. And we're going to do that using a join to array function, or method. So let's look at that. So here we are in Watson Assistant. This is what I call EBOBot. It's just an enablement bot. One of the things that we'll enable on is this creating phonetic libraries. Let's just try it out so you can get a feel for how it works. You'll see that it's going to offer up a number of enablement topics. The one that we're interested in is the last one here, converting a string into NATO dictionary equivalents. So we'll hit that and we'll select that. It'll say your password is ABC, capital ABC, lowercase ABC. Would you like to translate that to native phonetics? And I just need to tell it yes. And when we do that, it's going to then look up each one of, it's going to parse it, and then it's actually going to go look up each one individually and bring back the equivalent from the dictionary. It's that straightforward. So let's actually see how that got set up. So when we look at our steps here, the very first thing is parsing the string. So how do we do that? Parsing the string, of course, starts with the string itself. You'll need to identify what the string variable name is in your environment. In this particular case, the string itself is called temp password. If we go down here, you'll see here it says your password is capital ABC, lowercase ABC. If I go here to manage context, I should see in the $temp variable, I'm going to PQRST. So in the $temp password variable, you'll see that that actually is the variable. So in your case, this will probably be being submitted into the session from an orchestration engine. Whatever the actual variable name is, you'll just need to isolate that. Now, once you've isolated it, we now have to parse it. So parsing it is going to happen in the following way, using this substring method. And I'm going to give you a link in the deck to the substring method, but this is actually how you will execute it. So this assumes that you always know the length of the password or the string itself. So it needs to be of a fixed length. There are ways to accommodate variable string lengths, but in this particular demo, I haven't done that. It's going to be a fixed length of 6 characters. Of course, it could be 9, 12, it could be anything. If we're going to deal with varying lengths of strings, we would have to build a counter, and it would just be a bit more sophisticated. I don't think that that's the use case that we need to address right now, so I haven't gone down that path. But in this case, I just showed you the actual variable string is identified by temp password. And so what we're doing here, essentially using the substring method, is saying, hey, go pull the temp password, and now I want you to extract subcomponents from the temp password using this substring method. The subcomponent specifically that I want you to pull out is the very first character. And then we do the same thing for the second character. Do the same thing for the third character. The reason you see 2 numbers here is that the way this method works is you define the starting character and the ending character. There are times when you may want to pull out 3 characters or 4 characters in length. That's not the case here. All we want to do is identify each individual character of the password, which is why you see a 0 and a 1, a 1 and a 2. So this is essentially saying the first character, pull it out. In our case, the value that it would be pulling out here is capital letter A, and it's going to assign that to password character 1. We do it for the second one, the third one, all the way through to the 6th one. So using this setup, we immediately translate your password string into various different character components and then load them into these password character variables. So that takes care of this step, parsing the string. When you go to the docs and look at the substring method, and here it is, and here's where it shows you that you've got to define your string, that we're using the substring method, that we're going to do the beginning of the index and the end of the index in terms of the content for the substring method. You'll notice that it's very clean, whereas in the example that I'm giving here, there's some additional symbols here. There's like a ampersand, E, dot, and there's some other things that are going on here. We'll discuss that later. It's very important when you set yours up that you include these verbatim. So they are very specific to this use case. What these allow us to do is to use the array method later in the process. It's actually the next step. And so it's not super important that you understand why they're there. It's just important that you it's just very important that you include them. Okay, so that concludes parsing the string. Now let's go to the second. The second step is building the phonetic dictionary. And again, as I mentioned, this is going to be an array. And so this array, typically we define all of our variables at the welcome node so that happens. And so in our welcome node, we actually have a number of different variables, but one of them is this NATO dictionary. And here's where I've loaded in all the different values for my NATO dictionary. My NATO dictionary is very concise. It's actually an abbreviated version just because I'm doing it for this example, but I'll show you what it looks like in the JSON editor. So in the JSON editor, you'll see there's a number of key value pairs, and here's my NATO dictionary. So I loaded it with the numbers 1, 2, and 3, and then the letters A, B, and C in both their capital and lowercase versions. And what this allows us to do is when we submit a character for review into the dictionary, as it comes through here, if it's a lowercase a, it'll skip this because it is case sensitive, and it'll go down to the lowercase a line item. As I mentioned before, whatever you put in here is completely up to you. But this NATO dictionary is this simple. You're going to define the name of the array, and then here we're going to load in all the key value pairs for this array. In your case, I'm assuming this array will actually be fully blown out. You'll have every single number in here, as well as every single letter to handle all your alphanumeric possibilities. So once this is built, and I guess I should point out that this can be built in a couple different ways. One is you can just come in here to the context editor and just add a variable, which you're going to name, NATO dictionary or something similar. And then you can just you could copy this, because I'm going to give it to you, and just start writing it out. That's one way to do it. The other way to do it, I find it easier to actually just go into the JSON editor and do them in here, because I can actually take this structure and copy and paste it down and start filling it out that way. You could also do this in a Word document many times, build it out in there, make sure you have the structure correct. For some reason, it just seems ergonomically easier to work in an editor of some kind. It doesn't have to be Microsoft Word, of course. And then just paste it in here. This JSON editor will give you plenty of feedback on what it does and doesn't like if you are doing things that, like, for example, if I add a comma here, it's going to immediately tell me, hey, we don't like this, it doesn't work. So you're just going to have to be very specific in how you build it, that you follow the syntax that I am showing you here. Okay, so now once that's done, we're going to use that dictionary that we just built to actually look up the phonetic translation. This is going to happen down here. So here's what that's going to look like. This join to array method is essentially telling it, hey, I want you to go look up this array, NATO dictionary, and I want you to look for this value, password character 1. Since we've parsed the string password character 1, the value is capital letter A. So it's going to go to that NATO dictionary and actually look up in the library and return whatever needs to be returned. Okay, there's two things I actually need to circle back to before we wrap up. I had mentioned that there was a reason that I had added some additional characters when I go to make these variable values. And the reason really has to do with the method that we use in the join to array. So if I come down here and you actually look at the syntax for using this join to array method, you'll notice that before the variable that defines the array that you're going to look up, there is a % e dot, and then as a suffix there's another %. So I simply added those because otherwise there was no way for me to get those values loaded into these variables so that when I call them down here, they meet the requirements of the method to actually do the lookup properly. This is one of those few situations where understanding isn't nearly as important as doing. So if it doesn't make sense, it certainly isn't going to cause any problems as long as you actually format this with this syntax. If you do need to understand though, and the explanation I just gave doesn't make any sense at all, feel free to reach out to me and we can walk through it. Okay, the other thing is in the welcome node, we oftentimes use this node to create our variables and that we're going to use later in the application or later in the dialog flows. There are a lot of variables here in this demonstration skill. I didn't say it. None of these are important for this particular use case unless I specifically called them out. Conversely, if I called them out, they need to be mentioned here. So for example, I've got all these temp passwords, these password character parse values that I put into password character 1, 2, etc. So those are all called out here. If you've got 15 password characters, you're going to need to call out all 15 here, right? And then of course, as I mentioned, the array, of course, is also mentioned here in the welcome node. So those are the only two things, and that pretty much ends the enablement. I will just kind of recap what we discussed. Once you have some sort of string in your session, if you do want to make a conversion, in this case taking a password and converting it to phonetic alphabet, you're going to want initially to parse that string, which means you're going to need to explode it and take each of the individual characters and save them as in their own specific variable. Once you've done that, you're going to build a phonetic dictionary and look up each one of those individual characters and then ultimately read it back to the customer using a method array, or an array method. So that wraps it up. Please let me know if there are any questions and we can do a follow-up session live if at all necessary. Thanks.